For my Vehicle Engineering 2 project, I decided to build a miniature roller coaster. This is a project I've wanted to do since high school. The roller coaster and cart were designed in Fusion 360, and the entire thing was made parametrically so that any parameters could easily be changed, like the height of the hill, the track diameter, the rail spacing, the loop size, and so on. The cart was designed to be 3D printed, and it was printed in 3 parts that glued together with pins and holes to position the pieces. The wheel assembly on the cart uses the common configuration for today's invertible roller coasters, which consists of running wheels that ride on top of the rails, side friction wheels on the outside of the rails, and upstop or under friction wheels that run along the bottom of the rails to keep the cart from leaving the track during inversions or steep hills. These wheels are bearings that are mounted on M4 bolts which mount to the cart with threaded inserts. The cart was also designed with a coin slot to increase and decrease its weight to balance the momentum and friction losses. Lastly, it has a self-locking mechanism that works with a rotational spring and a hook that allows the cart to hook onto the lift hill chain and be dropped off at the top of the hill to reset the circuit. The track consists of a hill, a banked corner, a loop, a straight, and a final flat corner before being reset with the lift hill. The flat section was originally going to be a helix, but the process for bending this section ended up melting a quarter of the length, and the helix was too tight for the cart to travel along, so it was replaced with the straight for now. This is possible as every individual component of the track is attached to the next using bolts and threaded inserts so that pieces can be swapped out and the track can be disassembled for transport. 3D printed spacers superglued to the track keep the rails at a consistent 30 millimeters apart and were designed to snap in for easy assembly. The lift hill works with a motor and plastic chain that is constantly moving and lifts the car to the top of the track when it hooks on at the bottom. The track rails are all bent out of 1/4-inch 6061 aluminum round bar, and were all bent by hand using custom 3D printed dies, a manual roller machine, and a bending apparatus. The helix was bent by wrapping it around a rod on a lathe while heating the metal. All of the aluminum had to be annealed with a blowtorch, as the T6 aluminum had way too much springback and was therefore impossible to bend accurately. The 2 rails needed to be bent with high accuracy in order to keep the spacing between curved pieces consistent. This was all done over the course of about a month or 2 in the MAE machine shop. The rails had to be manually filed quite a bit at every joint to ensure the cart could ride over them, as assembling by hand with superglue was inherently very inaccurate. Unfortunately, there was still a lot of problems with the joints not being as smooth as the cart needed, and it would be halted on these discontinuities. For this reason, the cart does not fully make it around the circuit without help. As well, the superglued spacers kept breaking off, mainly due to the rails not being bent to perfect accuracy. This caused the rails to be constantly pulling away from the spacers and not contacting them across their entire surface area, making the glue joints weaker than anticipated. Also, due to the bending inaccuracies and bumps at the joints, the clearance between the cart wheels and the track was increased to allow the cart to ride over these problem areas. Unfortunately, this also caused the cart to be able to rotate slightly in straight parts that were properly spaced. The loop was especially hard to bend accurately as it was done by hand and with a rubber mallet around a 3D printed cylinder with grooves, and its 2 pieces ended up not being as accurate as intended, causing the cart to get stuck at the end quite often as the rails were not quite straight where they mated with the next piece. The spacers in this loop often were breaking off as well due to the bending inaccuracies. Overall, the build mostly works as the cart can complete the circuit when helped along the problem joints, and the lift hill works as intended. I will be continuing with this project after I graduate and improving the coaster by fixing these joints and possibly also replacing the hill with a larger one if the joints can't be made much better. I will also design and print proper supports for the coaster once its design is finalized and ensured to work properly. The cart will likely be improved as well to have suspension and/or a pin joint between the front and rear wheels. With this change, the cart will likely be able to ride around the tight helix, so this will be incorporated into the track as well. This project really demonstrated to me how much design is an iterative process, and I will be continuing to iterate it until I have built my dream mini roller coaster. It also demonstrated how long and tedious manufacturing can be, especially without CNC machines at my disposal, but I am happy I challenged myself with this project and have built something I am proud of. Thanks for watching the video about my roller coaster.